Hello guys, this is a continuation of problem set number 8, problem 1. So I left off here in part B with the charge for part B we're looking to compute the charge on each of the three capacitors nearest point A and point B when the voltage between point A and B is 420 volts. So that's these three capacitors, right? Anyways, just watch part 1 and then wherever that left off we're continuing here in part 2. So I found the charge for these capacitors right here. But I actually need to find the charge for this C2 right here, right? So right now I have the charge for C equivalent. But I now have to go back up here and find the charge for C2. So I'll do that right now. Okay, so right here, let's just write down that the voltage here is equal to 420 volts. So I know my C1, my C2, and I know voltage here equals 140 volts. Q is equal to 9.66 times 10 to the negative 4 coulombs. C1, that's obviously, I think it was 6.9 microfarads. So 6.9 microfarads. V also 140 volts. And Q equals 9.66 times 10 to the negative 4 coulombs. Okay. So now, let's find the charge for our C2. Okay, so I know C2 is equal to 4.6 microfarads. 4.6 microfarads. The voltage here is 140 volts, right? And here, now I need to find the charge. Okay. So to find the charge, I will use this formula for chapter 24, section 1, right? Paste. So my Q will be equal to C times delta V, which is equal to 4.6 microfarads times 140 volts. And that will give me 6.44 times 10 to the negative 4 coulombs. Okay? And so that will be my answer. That will be my other final answer for part B. So this is 6.44 times 10 to the negative 4 coulombs. All right. Moving on to part C. So with 420 volts across point A and point B, compute the voltage between point C and point D. Okay, and in order to do that, I'll just copy paste this process we did in part A. Okay. So I basically just went from our original diagram, our original circuit, and combined capacitors until I got to this part, right? So if you guys are curious how we got there, just watch part 1 of the video and we'll take you step by step. All right. Again, using this formula from chapter 24, section 1, the definition of capacitance is equal to charge over potential difference. All right. And we want to know the charge between, the voltage between point C and point D, right? I know that the voltage here is equal to 140 volts, right? This is from part B, right here. Oops, not that, right here. Okay. I know that C1 that was given in the problem, that's equal to 6.9 microfarads. This is equal to 6.9 microfarads, right? And I have these capacitors in parallel, so I know that the capacitance for these three capacitors on the rightmost capacitors of the circuit are equal, right? They're all 6.9 microfarads. And because they are in series, according to this capacitors in series part of chapter 24, section 3, the charge on each capacitor is going to be the same. So if the charge is going to be the same for these three capacitors, and we see that the capacitance is 6.9 microfarads for all of them. So based on this formula, we know that the delta V, or the potential difference, will also be equal between these three capacitors, right? Okay. What else do we know? We know that if we put all these capacitors in series and combine them, so it would look something like this, right? A, B, oops, C1, C1, C2, and then C equivalent, right? Since C2 has 140 volts right here, right? That's just, we saw that in part B, right? Then that means this will also have 140 volts, right? Because they're in parallel. And the potential difference across each capacitor that is in parallel is equal or the same. Okay, so we know that the delta V for these three guys are the same, and we know that the sum their potential differences have to sum up to 140 volts. So what we could do is we could just divide 140 volts divided by 3, and that would give us the voltage for these three capacitors, right? But more importantly, it will answer a question, which is that it will give us the voltage for the voltage between point C and point D, right here. So let's go ahead and do that. If we plug that in our calculator, that VC, the voltage between point C and D, is equal to 140 volts divided by 3, or 46.67 volts. So the answer here is 46.67 volts. And that will be the voltage between point C and point D. Okay, so this is our final answer for part C.